Today, AP Physics, we're going to talk about rotational kinematics, which is motion in a circular path. Now, because we're talking about rotational kinematics, rather than using linear units, which describes how far an object goes in a straight line, we are going to use what's called angular units. Which describes the rate of rotation. It's how much an object will rotate in radians or degrees. So let us simplify some of our symbols first. So instead of using displacement, we are going to use theta, which is our angular displacement. Okay, and just like our displacement is in meters, okay, instead of using meters, since we're going around a circle, we're going to use degrees, or otherwise in physics we use what's termed radians. Okay, so to understand this first before we go on, when we look at a circle, okay, we know that if we start here, we have 0 degrees. Going up here, we make a nice 90 degrees. Coming over here, we have 180 degrees. Okay, but what is the conversion from radians to degrees? Well, 1 radian is equal to 57.3 degrees. That is not a nice number, okay? But we can write out an equation for this. So for 360 degrees, which is known as 1 revolution, is actually 2 pi radians. Okay, and we can simplify this even more. 180 degrees, because if we divide 2 by 360, is just pi radians, okay? Which is what we're going to be using more than degrees when we are doing our calculations. Okay, so let's further go through this, okay? So this is a linear unit, okay, meters. So we're going to be using degrees and radians for our angular displacement, okay? Instead of using velocity, we are going to use omega, which is our angular velocity. You see how that goes? Now, angular velocity is in radians per second or degrees per second. Very similar. Okay, and then we have acceleration. Instead of acceleration, we are going to be using alpha, which is angular acceleration. Okay, and what if you can guess it? Because acceleration is meters per second squared, we're going to use radians per second, or radians per second squared. Okay, so let's see the side-by-side comparison from linear kinematics to rotational kinematics. So I'm going to be using our units for rotational kinematics, and I'm going to just be plugging them in for the equations. So now you know the majority of the equations we're going to be using for rotational kinematics. Hope that helps.